So challenge 3. We left off here. We left off here basically where I started to move into what challenge 3 became, but I was kind of bumping into some issues. But anyway, what we identified essentially is that the surface itself can be used as the curve and the plane input. And I still to this point right now can't explain all of the intricacies of why we were having those corner connection issues, but anyway, this is what works. And so you had this at the end of yesterday, and so this is where you should have began. What we were doing is cutting out, and I think I even gave you the term cutting out or trimming out or something like that, from the center a smaller triangle, right? So we're offsetting the edge or the size of the triangle inward a certain amount. And so in this case, my positive value is going on the outside, and so I'm going to switch that to a negative to make it go on the inside. Just like that. Okay, so I think you all got to this point just fine, and I think for the most part you all even got the subtraction part just fine as well. And the subtraction part is a Boolean function, which, if you'll recall, happened under the intersect menu and under the shape panel, right? So this solid union, solid intersection, solid difference, those are your Boolean functions. But you also need to be aware that sometimes solids actually require a volumetric solid. So if I recall correctly, this might give me an error. So I believe it's this at the top and then this one at the bottom. Okay, so it worked. I thought it gave me an error before, but anyway, so I'll turn these back off, and this is what you get. You get a flat plane that just has an offset edge, and then you can just cut it out. So the next part is trying to figure out how do I give it thickness, right? So the example that I showed had a rectangular or square profile that went around the entire frame. In order to do that, I essentially just need to extrude it, right? That's the simplest way of getting a rectangular or a square profile around a frame, extrusion. But in order to do the extrusion, I need to extrude it in the direction that the panel is facing, which means I need to find that panel's surface normal. So I'll work backwards from the extrusion, and under surface freeform, the tool extrude is right here. And it's going to ask me for the profile curve or surface, and then it's going to ask me for the extrusion direction. But we know that the extrusion direction needs two things. What two things are those?
Vector and...
Well, I should rephrase that. The vector needs two things, and I already gave you one of them, direction. Or it gives you one of them, and it's direction. The other one is what? What's that? Magnitude. Close enough. So in order to do the magnitude, you go under vector, and it's this one called amplitude. I wish they just called it magnitude. It would have been nicer. So amplitude is what we're going to have plugged into the D input. Okay, and so amplitude is going to request those two components. It's going to request the base vector, so that's your direction, and it's going to ask for the amplitude, which is your magnitude. So the surface that we're going to extrude would be these. And now we just need to give it that direction and magnitude. So simply put, the magnitude can be a number of things. If it's going to be square, then the magnitude is just going to be this. If you're doing a square profile, it'll be exactly the same as the offset of the curve on the edge. That way it'll extrude that same amount. So then we need to find the base vector. Does anybody recall how to find the base vector? I'm looking at you, Roger. How do you find the base vector? That's all right. If you can't formulate it, we can move on.
I don't know.
Okay. Well, it looked like you had it correct, so I get maybe it's just you. Yeah. Maybe my question isn't clear, but anyway, so the base vector is found by basically extracting the surface normal using your surface analysis tools, right? So under surface and analysis, there are a couple of tools here that we're going to use that we've used a couple of times and that I want you to, as we move forward, commit to memory. The first one is the area tool, which I think we're all starting to understand now. We use the area tool to find the centroid. So we'll use that. The other ones are a pair, and primarily they're going to go together in almost all cases that we use them in this course. And it's surface closest point and the evaluate surface. So these two go together because evaluate surface requests a UV coordinate value or a set of UVs. And then what happens with surface closest point is that it measures a list of points or a sample of points, and then it also measures a surface, and it gives you the UV point location on that surface. So that's why they're paired up together so clearly. And so the UVP, I always just connect it really fast like that. And then the surface difference, the area is going to come off of these cut surfaces. It actually doesn't matter which one you use. You could use this, that, or you can go all the way back to this because it's going to give you the same centroid. But I'll use this because it's the latest geometry I have. And I plug that into the points value input. And then likewise, we plug the surface into the surface input to test for surface closest point. And then I also plug the surface into evaluate surface. And here you can see those frames are orienting themselves to the planes. But most importantly, the thing that we really just need is the direction. And that's this right here, the n value. So the n is the normal at that particular UV location that you extrapolated using these two tools. Is that clear? All right. So anyway, the normal gets plugged in here, and that's how you get the extrusion. Oh, look at that. Why'd it go so far back? Oh, I know why. Can any of you tell me why it went so far back? Why this extrusion went that far back?
Is it trying to connect to the other plane?
Good guess, but no.
You need another. Oh, the value of negative is too high.
Yes. But what am I going to do to it to make it correct? What's that?
To give it another value is lighter.
A smaller value? Is that what you're saying? Yes, we do need to make it a smaller value, but how? What's different about the two connections that this is making?
It's all one.
Oh wait, is it triangular?
No. So the difference here is this distance input has an expression on it. Because I put that expression in there in order to convert feet down to inches. So when I plugged it in here, I forgot to include that expression that's going to reduce the value from feet to an inch factor. So yeah, precisely. Right click on the input, go to expression, and you can do x divided by 12. There you go. And that's pretty much it. All right, so the key about that is that now whenever I change the thickness of the frame, it changes in both directions now.
And does the panel, does that stay a center point for that
What do you mean? Oh, is it on the center line of the curve that created it? Is that what you're saying? No, it's not, because it's basically this curve is the outer edge, this is the offset curve, and then I extruded it back. So it's not center line based. It's a good question. Any other questions? All right. So I'm going to save this, give you a chance to get caught up, and then we'll move into a little bit more exercises, a few more exercises that we're going to need. Did you have a question?
Kind of.
Oh, a specific. Okay.